Given three non-coplanar vectors A, B, and C, check whether the following three vectors are coplanar or not. Okay, let us begin. Now what we'll do, we'll first, for simplicity purpose, we're going to name the three vectors. Let's say A vector is represented by A vector plus 2B vector plus 3C vector. Then B vector is going to be represented by 2 times A vector plus B vector plus 3C vector. And then we have this vector C. So C vector is going to be represented by A vector plus B vector plus C vector. Now we need to show that these three vectors are coplanar or not. We need to check that. But however, what we'll do, we will start with an assumption that these three vectors, A vector, B vector, and C vector, are coplanar. Now, if they are coplanar, then it must immediately follow that if we pick up any one of the vector, let's say we pick up the vector A, it can be expressed as a linear combination of the other two vectors. That means we can represent it as x times B vector plus y times C vector, where x and y are going to be two scalars. That could be any two real valued scalars. Fine. Our goal will be to find out the values of x and y. We'll come back to that in a moment. First, what we'll do, we will use the values of A vector. So A vector is A vector plus 2B vector plus 3C vector. That will be equals to x times the vector B. So we have x times 2A vector plus B vector plus 3C vector added to y times the vector C, which is A vector plus B vector plus C vector. Now what we'll do, we'll combine all the common term. So we get 1 minus 2x minus y. That will get multiplied to the vector A, added to 2 minus x minus y multiplied to the vector B, added to 3 minus 3x minus y multiplied to vector C. This is going to be equals to the null vector. Now here we're getting a null vector because on the left hand side we're operating with vectors. So if we are adding vectors, then we should get vectors on the right hand side. Now as given here in the problem that A vector, B vector, and C vector, these three vectors are non-coplanar. It's given initially only. If they are non-coplanar, that could mean only one thing. The coefficient of A vector, B vector, and C vector, they must be equals to 0. Only then this particular equation is going to be true. So that means this implies we have 1 minus 2x minus y equals to 0. We're going to label this as equation number 1. Then we have 2 minus x minus y equals to 0. Let's label this as number 2. And then we have 3 minus 3x minus y. So that's going to be equals to 0. We're going to label this as number 3. Fine. Now, what we'll do, we'll solve any two equations at a time and try to find out the value of x and y. Now, let's do one thing. Let's take equation number 1, and from here, we're going to subtract equation number 2. Now, we have 1 minus 2. That's going to be negative 1. Negative 2x minus negative x is going to give us negative x. Then we have negative y minus negative y, so that's 0. This will be equals to 0, which gives us the value of x as negative 1. Now that we have the value of x, we can use either equation 1 or 2 to find out the value of y. So let's use equation number 1. So we have 1 minus 2 times negative 1 minus y equals to 0. So we have 1 plus 2, so that means y value is going to be equals to 3. Now that we have the value of x and y obtained after solving 1 and 2, we'll have to check if it satisfies number 3 or not. So that means equation number 3. So we're going to use equation number 3. So here 3 minus 3 times x, so x value is negative 1 minus 3, so this will be equals to 0. So we have 3 plus 3 minus 3 equals to 0. That gives us 3 equals to 0. Now that's incorrect, we know, which means that our initial assumption was wrong. That means A, B, and C vector were not coplanar. That's why we're getting a wrong statement here. So we can say thus the three vectors A vector, B vector, and C vector are non-coplanar vectors.